Hello everyone. First of all, welcome. Thanks for joining me this afternoon. My name is Dhameja, and in this particular workshop, I'll walk you through with the token curated registries concepts, why they are there, what particular purpose or use case they are solving for distributed or decentralized systems, and then finally looking at an implementation as well, which is basically a simpler version of what is a little more formal and famous these days, the Mike Golden's implementation, and then how we actually are using them in some of our projects as well. So let's get started. And before jumping into the details, let me quickly ask you guys a couple of questions. Like, how familiar are you with smart contract solidity and stuff?
Pretty well. Building DApps.
Okay, cool. And have you seen token curated registries or the concepts or the details before?
Yeah, integrating to
Awesome, awesome, cool. So thank you so much for already looking into this stuff. So that makes it easier for me to cover this all of it in 2 hours. So there are some seats over here. You can feel free to take them, and I can actually evacuate this one as well. So. Okay, so I will, the agenda that I have for this workshop is basically, I'll walk you through some slides just to cover some basic concepts. Some of you are already aware, like I asked previously, and for the others, it will be a quick walkthrough of what the concepts are. And then basically we will jump into the code with implemented TCR. So the first idea of token curated registry, at least the idea that I'm aware of currently, is from last year when Mike Golden published this blog post called Token Curated Registries 1.0, and this came out September last year. And then after that, there have been a lot of other frameworks which are built on top of them. One of them is Stake Machines, which I co-did with one of my colleagues, Dimi. And then there are others as well, like layered TCRs, graded TCRs and stuff. But the primary concept of a TCR has been almost the same, exactly the same, since this blog post came out, and they are being used in several systems now. I have seen a few projects, I've done a few projects myself where we have used some TCRs more recently. So, but the original idea came somewhere 1 year ago from Mike Golden, and the idea is now in production, implemented in AdChain registry. So there is a registry called AdChain. If you know about TCRs, then you must be knowing about AdChain as well, because that's where it is coming from. So the idea is that there is a whitelist of publishers where publishers or people applying for a position in this whitelist can submit domain names, and people who are aware of those publishers or who have worked with them can actually challenge or vote for or against these domain names, so that they can stay or be removed from the whitelist. And generalizing that idea, then basically not just publishers, it can be applied to, well, anything else which can be done using community-driven curation. So that's where we are going to generalize this a bit in this workshop, look at a broader concept of community-driven curation using TCRs, and then how they are helping in the decentralized systems. So to cover the very basics of TCRs, we only have some simple primitives over here. We have a list basically, which we call a whitelist, and then and then if this is a list, then there should be items added or removed from this list. Now that is not being done from a direct user, or not being done from one particular person. It is being done by a community of or a group of people. And then we are basically adding and deletion of these items from these lists using through this community. We are calling that curation. And then finally, to do this, to take these actions on the list, or to at least participate in these actions in the list, you need something of value. and that something of value can be represented as a crypto token. So that's where the token is coming from. So there's a list. To add or delete items, you need something of value, which is a token. So that's basically TCR in one sentence for you. So now let's basically go into details or jump into each of these concepts or primitives of a TCR. There are some details, minor details associated with each of them. So the first one is the list or the registry itself, where we need to add or remove items or maintain a list in this. So there are two more important things. This is just a binary listing. There is no intermediate step. It's just simple as if an item is there on the list or not. Either it is inside it or it is not there. There is no application, you can say, there is no process where it is going to be there someday or not and stuff like that. It's fully binary. And secondly, and more importantly, is that basically, I think that's one. And the second thing, I'll come back to it, but there is one more important characteristic of this list is, and let me follow that up in the next couple of slides. So the second more important thing is basically you want to add items to this list, or if you are not happy with an item which is already there on the list, you want to get them removed from there. So that's where some functions come into the picture, which are curation functions for TCRs. So like if this was being maintained or this was being done by one single person, he would just have a simple function called add or remove. But that doesn't work when you are working with a community, when you are basically working with a group of people. Everybody has their say. So you basically say propose. I would like to propose that this item should be there on the list, and I am willing to back my crypto tokens for this proposal. That's how a community should be involved in a process driven by this particular group, and not single-handedly like add or remove. So that's where we get this idea of proposals. In the implementation, it's called apply, and then there are some parameters associated with it, which I'll come back later. Then you basically, once you say that you want to suggest something should be added to a list, there will be people who will say no, it should not be, and that's where the challenge comes into the picture, that this particular item should not be there on the list. If it is already there, then let's have a contest. If it is not already there, then also let's see why it should be there. And finally, when we have a party which is interested in getting it in, and then we have a party which is interested in getting it out, we need the opinion of the masses to choose which one it should be, because it should not be like, again, like it is not being done by one single person, so voting. So once there is a challenge, once there is basically enough, you can say, opinion about something that it should be there, it should not be there, then we say we need to vote on this. Let's figure it out how basically we resolve this thing. So we need people to vote, whether they support the items addition in the list or they want to support items removal from the list. So these are primarily the three most important or simple curation functions in a TCR. You need to propose, you can challenge, and finally you can vote on this. Now again, if you can see, it's when I said previously the list is fully binary, the item is there or not. Similarly, the vote is also binary, it's either 0 or 1. It's like if there is an item which is being proposed and you are voting in favor of this item, that this should stay or remain on the list, you are saying yes or 1 and something positive. And if if your opinion is that this item should be removed from the list, then you are simply voting a 0 or a no or something like that. So your vote again becomes a binary, and this binary mechanism actually keeps TCRs very simple. Yes, and now coming back to the previous point, which I forgot in the previous slide, was there is no ranking also. So there is, when you say that item is in a list or not, these items are not sorted. These items are not having any weight with them with respect to basically being better than each other. It's just that they are on a whitelist. That means they can be trusted in a specific context or in a specific scenario, or they should not be trusted in a specific scenario. They can be negative whitelists also. So for example, bad authors on Wikipedia. So like these are primarily the three functions, and again the basic idea of a list, why this list is there, what initial, you can say, functions it provides, and how you perform those functions. Now I'll go back to the previous definition that I gave on the first slide. Was to do these functions, you need something of value, because if you don't have that, if you don't have something of value with you, you cannot perform these functions, and that is where the token comes into the picture. Now there are a lot of things of value, but why a token is needed in this particular registry, why there is a token for every registry, that is a more important question that comes when we talk about TCRs with tokens. Why do you need a token for every registry? So the idea and the basic principle around that is the incentive system or the economy associated to a token curated registry should be basically related to, or should be showing the overall value of the items in that particular list. And by value I mean the value to the consumers who are consuming this list, and it should not be dependent upon anything else. So if I'm using a token which is actually volatile because of external factors, Bitcoin, Ethereum or something which is actually whose value can be impacted by other factors, not just the items in this list, then that is not a real, or that token should not be used over here. So that is the reason why we have tokens for each of these lists, that value of this token should always be dependent upon the overall value which is being you can say supported by the overall registry to the consumers. So that is why we need a token. And now let me give you a pictorial representation of some sort of TCR cryptoeconomics on why how this particular token is bound to the TCR. So primarily we have three different actors in a token curated registry scenario. We have the applicants, who are the people who would like to propose that something should be there on the list. We then have curators, who may or may not choose to challenge these items on the list. And then we have, and out of these curators there will be voters as well, there will be challengers as well, but that is the community where we are looking, which will help define, or which will help you can say decide whether an item should be there or not on this list. And finally we have consumers, because those are the most important you can say actors in the system, because if nobody is consuming a list, then it's a useless list. So it is always important that the more number of people consuming this list, the higher value of token will go, because then there will be more value for people who are on the list. So it's all basically related to each other if we remove the external factors, and that's why a token is needed for every registry. So for example, let's take a simple example, that there is this @chain registry, which is basically a list for whitelisted domain names of publishers. So if this registry really has a value, then the overall you can say value of this particular token will also rise, in a way that when you want to put your item on that list and you are already getting ads because of this particular list, then more number of people will come in and they want to have their application for this particular list. The more demand of token will be there, and because the token is basically you can say a predefined number of tokens are there for every list, and the value of the token will rise. So if the registry is important for the consumers, then the value of token goes up. So it is a win-win for everyone. And why the value of registry will go up for the consumers? Because if curators are playing fair in this game, then there will be only good entries in this particular registry. And then people will start taking it seriously, and hence the value of token will go up. So everybody's interests are involved here, and they are obliged to play fair. Otherwise, there is a mismatch in the whole economic incentive scenario. So this is basically and let me also point it out that there is a concept called circle of crypto economic activity. It was I first saw it on Joel Monagro's slide last year in token engineering workshop, or not this year actually, in May. And I have just basically put these actors in that kind of concept. It's basically how crypto economics of a particular system can work with their actors. So, but I will take a small pause over here, and I will basically ask if you guys have any questions at the moment, or am I making sense? Is it becoming clear a little bit for you on how DCRs work, what they are, or do you want me to go into a little more detail, or do you want me to rush through this thing?
It's fine.
It's fine? Thank you. So, so we went through our primitives, but there was one more thing which was which I did not cover at the moment, and those are the parameters. So when there is a community involved in a system, you need rules for everyone with which they can play the game. For every sport you have rules, for every basically democratic process you have rules. So similarly you have rules with TCRs as well. So you can propose but within a specified amount of time. You can challenge but in a specified amount of time with at least the number of tokens for proposal. You can actually vote, but again within a specified amount of time, so that there is no, you can say everybody is playing with the same rules. There is no, priority or advantage being given to one single party. So that's where the parameters come into the picture. So some of these parameters are, you need some sort of, you can say predefined value that you need to have in your wallets to apply for a particular list, and that is for every list it can be different, which is called minimum deposit. So if you want your particular let's say entry into a list, you are a person who wants to apply that this is my domain name, it should be there in the list, then at that particular point in time, if the minimum deposit says 100 tokens, then you need to put 100 tokens behind your application, otherwise it will be rejected automatically. Then there is applied stage length. Once you have applied to the list, there is a predefined amount of time, which basically is again decided by the community on the list, is when you can actually challenge it. So if I'm applying for something today, there can be a X number of days or a Y number of seconds for this particular listing, where you can come in and challenge it. If you don't, then it gets accepted automatically. And then we have basically a deadline for voting as well. So if somebody has already challenged my listing, then what should be the time given to the people who can come in and vote on it? If they cannot, if they continue to vote endlessly, then it will never be resolved. It will always be in a state where it can be accepted or rejected. So to keep it, you can say, bound by time and realistic, we need these parameters. And finally, there are other parameters also, basically reveal period. So in the real implementation of or generic implementation, I should say, of TCRs, which is done by the AdChain team, there is a concept of partial lock commit reveal voting, which is basically you can vote on something, but you can come in and reveal it later. You don't have to basically show your vote in the first place itself. And that's basically when it depends upon the reveal period and on when you can actually come in and reveal, because after that you cannot, and your vote will not be counted. We have dispensation percentage, which is basically how much of the rewards should go to the winners. So once everything has been staked in from application, from challenge, from votings, how much of that should be going towards the winners. And finally, we have the vote quorum as well on what should be the percentage of votes counted towards for a past vote. So it can be 50%. So if you have majority more than 50%, then it goes to the winners, or the proposal has lost. And similarly, it can be any other percentage as well. So these are the parameters which are basically bound to each and every token creator registry, and they are also decided by the community, so that everybody is playing with the same rules. Yes.
So it's the winners, but I mean, who are the winners and losers?
So in a typical scenario, when you have reached a stage where something is challenged, then there are votes coming in. So which way do you have more votes coming in, more weighted votes coming in? So it can be towards for the challenge, or it can be for the for the listing as well. So that is basically which side you are on. Then you are a winner or a loser.
Right. And if there is no challenging, then
if there is no challenging, then if this apply stage length has passed, then it automatically gets accepted. So if there is no challenging,
so
there is no voting.
wins, basically, or
So then there is no voting actually. If there is no challenge, there is no vote. So voting will happen only when there is a split of, you can say,
right.
Opinion.
And the vote was a secret, right? Like you don't reveal your vote until the end.
Yes, yes. So
So you cannot, because I was thinking like, if you see that is going through the yes is winning, you can just stake yes, and then
exactly.
It gets diluted.
Yeah, there will be colluding if you keep your votes revealed from the beginning. So yeah.
Yeah, and the challenging deadline. That is for the initial publishing, or for the applicant trying to suppose submit a domain and get published. But if the domain is published and that domain brings negative value to the list, it can be challenged anytime,
Yes,
right?
yes. It can be challenged. So, and as soon as there is a challenge, there are votes. Yes, please.
What about Sibyl attack?
Come again?
Is this thing protected against civil attack?
Mm,
Can I create 1,000 accounts and give my proposal 1,000 votes? Yes.
you can actually. Yes.
Isn't it a problem?
It will be a problem for sure, but you will need those many tokens with all of your accounts. You will have to put, with each and every vote that you are putting in, you have to put in tokens. So if you put it from one account or 1,000 accounts, you are putting in the same set of tokens.
Okay.
So then how is the initial tokens generated and distributed to avoid bad actors having those tokens?
So there is no, you can say, decision on bad actors having these tokens or not. It's all built into the economic incentive of the TCR. So you have to get your tokens just like any other ICO. It's a simple ERC20 token. And then basically you have to back your votes or challenges or applications with these tokens.
And why not do it in Ethereum?
Like I mentioned, Ethereum's value depends upon a lot of other things, just not on this particular list.
Yep.
So if the value of Ethereum is dependent on other things, and it is not directly, it is actually bringing in external factors into the economic equation of the TCR.
Okay.
Yeah. Yes, please.
Are there examples of of like TCRs that are basically using, I don't know, like the token model where there's not a finite supply, or for example where it's like an exchange of Ethereum for one of these tokens, for example?
I am not aware of such examples actually.
Okay.
But there, I don't see why not. There could be bonded curves related tokens and stuff, but
Is
I'm
it
not
usually just a finite cap on the number of tokens?
usually, yes.
Oh.
And at this moment, I think we have seen only one real implementation. So, and then the second one, which we are doing in Ocean as well, is also with a finite number of tokens. So at this moment, I'm not aware of other implementations where we are using dynamic number of tokens.
So are you using dynamic number of tokens or fixed?
Fixed.
I didn't understand. So it's a ERC20 token, and you just buy it to enter in this system. You exchange it for Ether, for example, and get this token.
Yes.
and it's not this token gives you like voting power.
Yes.
It's not like you are paying for voting rights.
Yes, you are paying for voting rights, but then your vote really depends. When you are voting on something, you are putting your rights on stake.
Yeah, but with more money, I get the decision in the direction I want, and this way I get more money. I mean, if I pay just enough money, I make the vote to go my way and get the money from the nodes, for example.
But how will you know that the vote is going your way, because votes are not revealed?
Yes, I don't know. maybe I can see how many transactions there are, so I just make enough votes.
Yeah, I mean, those will be the total number of votes. You will, even if you are actually looking at the number of transactions or details or anything, and everything that is going inside as a vote is just a hash. So you will not be able to figure out what it is. So which way it is going will not be,
because in the same contract there's multiple TCRs, or a contract is just for one. So I mean, it's by the transaction where are the people voting in or not.
No, you cannot.
You can.
Where are the people voting in?
Well, how do you verify it?
What vote? If I voted yes or no, how will you know that until I reveal it?
Right. But then I can, if I keep challenging a vote, I put something on the list, I take something off the list, I put it back on the list, I can reverse engineer who was putting these things on the list, right?
I don't get your question.
But you are sustainable to not a 51% attack, but you could say it like a 30-35% attack by looking at the votes, the transactions that go into the smart contract. You can say, okay, there were 100 votes, and you can by, statistics say that at least 10% or 15% are in your direction anyway. So you can just, if there's 100 votes, you just go like 30, 50, 35 votes in your way, and you sway it in the way you want to.
Yeah, I think you can do that.
Okay.
Yes.
To submit a proposal, do I have to hold the token already?
Yes.
Okay. Do I also get rewarded if I would vote for myself, and this way I would get rewarded in case the proposal is accepted?
Yes.
Right. And last question is the amount the amount of tokens that you stake on a proposal, is that the same one for everyone, or could you stake more or potentially less, depending?
You can stake more, certainly, because this is minimum deposit, so you need to have at least that.
Yes, please.
Yeah.
So this construct is basically it's based on there being a kind of a speculative value of the token that in question. So presumably there will be some kind of equilibrium that the token reaches. It will equilibrate at the value that that accurately reflects the quality of the list. At that point, there's no longer pressure to hold the token. So how do you prevent mass exits of the TCR and devalue the list? It seems like on the while there's upward pressure and while there's still speculative value, the list could be it's protected because there's still incentive to continue curation. But as the list is collapsing, how do you prevent that?
I mean, one way that I see it is if you are on the list and it has reached an equilibrium, why would you like to exit from the list?
Because you can't make any more money by holding the token.
It's not about making money by having your by exiting. It's more about if your entry or if your proposal is on that list, you are being you are in a whitelist, which is basically important for other consumers. For example, this particular ad chain registry is important for people who want to put their ads on these publishers. So New York Times or WSJ, they always want to have their name on this particular whitelist when it reaches that particular level of equilibrium, so that whenever there is a new person coming in who wants to publish some ads, he's looking at this list and looking at people who are already whitelisted. If at that particular time you are already exiting, then you lose business.
So you described a scenario where it's important for the New York Times as stakeholders to be on that list. And one, that's not always the case, that they're actual like stakeholders in if you're doing, for example, artificial intelligence data or something that is there aren't actual stakeholders that you can point to, then there need to be the curation incentive needs to come from token holders alone. And in that case, it seems to me like there needs to be some incentive to continue holding the token. And if there's no way for that token to increase in value anymore, then it seems like that wouldn't necessarily work.
So if you stop holding the token, then in that case, basically you are simply allowing any other person to come into the list, and then the list becomes less valuable because it has bad entries in it.
Right. But you've exited the token completely, so you don't care.
But once the list gets back, or maybe let's take it offline because I need to really cover a lot of things. But I will actually touch base with you. Let's discuss this. It's interesting. So yeah, let's basically move on, because now I have finished covering all the concepts on what TCRs are, what are the functions involved, why there is a token, and what are the rules, parameters involved.
What's a good example of a list? Like, I'm just thinking, like ENS name registry. Is it what's another example of a list?
A Spotify playlist, decentralized, curated.
Top hotels in Berlin.
I suggest we use ad chain as an example because it's like more we can all relate to
It's
it.
more implemented, so it
Ad chain. sorry?
ad chain.
Okay.
So it's a white list of publishers.
Yep.
To, you can say, have all the good publishers which are playing fair, have on the same place, so that when somebody wants to publish their ads, they can look at this list and post their ads to these publishers.
Okay. Thank you.
But a curated music list is also a very interesting idea. In AdOcean protocol, we are working on something similar called Music Map.
And one question, there was in the Ocean white paper, there was this concept of applying for it of bonding curves. I think was it for the PCR elements or for the data sets? And
So
you never mentioned that. So is it, or it's not implemented yet?
it's still a lot, you can say, under architectural review. So I wouldn't want to comment on that part. So there are a lot of things which are under progress at this point. AdOcean protocol. Yeah. Yes, please.
Quick question regarding the voting. So if I'm a voter, I have the minimum required stake to enter the PLCR. And if I challenge everything and I lose all my tokens and I go down to say 1 token, do you guys have code where they get removed from the PLCR, or how does that work?
When you lose everything, what get removed?
Like my voting rights, I guess. Well, you are using tokens, but if you do it so that it's evenly weighted, I guess is what I'm thinking. But it's true that you use the tokens for the votes themselves, but you want, I guess, maximize the number of votes or tokens each person spends, right? Because you don't want someone to just be able to, or maybe you do put down 1 million tokens and just own the registry, but I guess you'd want, I mean, when they just run out of tokens, they can no longer vote. So.
Exactly.
Yeah, it's really question.
Okay, so I see some of us have laptops here, so if you want to see along what I am going to show you next as code, please feel free to clone the first one. front end is something that I wanted to show, but it's not fully complete yet, but I will finish it off in the next few days, which you can clone later. But contracts is something that I've implemented, a very simple version of a TCR. It's not, you can say it's only 20% of my Golden's implementation, but it helps walk us through the concepts which I've covered in the slides previously. And I will walk you through with this code. So, yes, please.
We are open for questions?
Yes, yes. In the meantime, we can actually cover a couple of more.
Okay. In the meantime, of what?
Some of us are cloning the repository.
Oh, okay, okay.
Yeah.
Sorry, I missed the part of the presentation. I just understood that it was here. Did you show the front end, how it will work on the front end? Have you worked on that?
No.
No. Okay.
Can you probably show ad chain?
Yes. I think
It would be of great help. They even have tutorials and a really good help section. They explain like screenshots and everything.
Okay, so this is basically like you also just now asked, how does a front end look like? So this is a front end implemented by the ad chain team for their token curated registry. So what we see here is that there are entries. This is the whitelist, which is basically the list of domains like we saw earlier. We see twitter.com is there up on the top, and if we click on that, we will see the history on when it came into. So it also tells me how do I challenge. So they have some tips over here, but I will walk you through this. So there is a history over here that the application was made, and then it became in the registry. There was no challenge, so it was applied and then it was accepted. Similarly, there are basically, so to challenge this particular registry or a listing in this registry, you need at least 1500 ad chain tokens because that is the minimum you need for this. And then if your this is a dispensation percentage over here, which we saw on the previous slide, that you have some sort of how much the number of tokens should go to the winning parties. So this you can see that is a life cycle of a one particular entry in the list, and then we can actually look at other. So if you go to the governance section, there you go with these parameters which we just saw. So we have minimum deposit, application stage, commit stage, and all that. And then you can actually, if my MetaMask was connected over here, I could have seen whatever is going on with my particular portfolio in this registry. And then basically there is this registry which is actually rejected as well. So let's see what happened to this one. So it was applied, then it was challenge succeeded, and it got rejected. So I should zoom in a bit.
Can you show the view transaction?
Which one?
Down to the right, the list.
In the middle.
Yeah, in the middle. Sorry.
Yeah. Yep.
VUTX.
VUTX. Nice.
So it is calling the apply function of the smart contract basically when you are applying.
So if variety got rejected, can they apply again?
Yes, that's why basically when you go back here, there's apply button for this particular, because they got rejected, they can actually apply again.
But I get to see who rejected me the first time.
Yes.
It's not a secret ballot.
It's not who rejected you, because it's a vote that happened and multiple people.
Yep.
So it was rejected by the smart contract based on the logic.
And I'm not completely clear on the token economics. So if I apply and I get rejected, would I lose the money?
Yes.
So the 1,500. And then in case that I win, is that the 60% that you mentioned before that is being spent across the people who have voted for me?
Yes, but there is a minimum amount of money that you have to keep staked for your entry. You can actually slash your stake as well. So for example, if you put X tokens, those are staked for your entry in the beginning. You can actually take X. So if somebody has challenged, you can actually take the amount which is more than the challenge. So if you are saying that, oh, somebody has challenged my entry and I might lose the money, you can actually take it out from the registry as well. But you have to put at least the minimum which is there for the challenge, so that the apply and challenge have the same stake behind them.
And then however people are rewarded who participated in the challenge, that depends on how much they were putting at stake. It's a percentage distribution between them.
So when you challenge, when you vote, then there is a pool of tokens coming into this particular process. So you need to decide how much percentage of this particular pool goes to the winning parties and what stays back or what is given back to the losing parties and stuff. So that there is always, like, you do not lose everything, you still have something coming back as a consolation.
Yeah, and the way it's distributed depends on how much each party was investing in that.
Okay, so so this is how it basically works. You can actually apply, and then this is the kind of life cycle that we saw for a couple of entries. And now I will walk you through with the smart contracts that we have. So let me zoom in. So a lot of this code is directly taken from the AdChain registry. I'll say it again because even the comments are taken from there. But just to make it simple, I have stripped out a few parts. When you'll clone this repository and see the readme.md file, you'll see what I have actually removed, what I have kept in there. But the idea is to keep it very simple, that you can apply for a listing, you can challenge it, you can vote, or multiple people can vote on it. And then you can go and resolve a listing, whether after the commit period has passed, you can actually go and resolve it, whether the vote has passed or not. And then finally, once the challenge has been resolved, you can go and claim your rewards if you were in the winning side. So it actually strips down all the you can say advanced or complicated parts, which are actually very necessary in a real life system, like revealing of votes. When in this particular contract, I'm just passing a true or false to keep it simple. But in a real scenario, you will be passing a hash, and then you will be revealing it at a later stage, which is coming from the PLCR voting contract developed by the AdChain team. But I'm not using it here. Then I am not using dispensation percentage and reveal period length reveal, because there's the votes are already revealed. I don't need that parameter in this one. And then dispensation percentage is something that I have a formula hard coded in the system, which is basically being used for all the challenges. So I do not have a custom percentage for winners. I am also not using a couple of other things like exits. So exit is again something that you can do at a later stage of time when you don't want to stay in the registry. But just for understanding the curation aspect of it, I've actually removed it as well. So this is a very, you can say, stripped down hello world version of a TCR. But whatever concepts I covered in my slides previously, they are all covered in this one. So let me walk you through with how this is implemented. So I have a struct for having my listings, and again, this is exactly the same that we have in AdChain implementation. But I have a couple of other things added here, which are basically making me get the data quickly in the UI. I didn't want to implement a cache or something for this particular implementation. So there are a few things here and there which are just to keep it simple but dirty. So but again, in a real DApp, we will not be doing this. Again, coming back to the second struct that I have here is a vote. So, but before that, is it visible till the end now with this zoom level, or should I zoom it more?
It's okay.
Okay. So the second struct that I have is a vote. Like you can see, the first is a bool value, and this is exactly true or false, whether we are voting in support of something or not supporting something. The amount of tokens that you are putting behind this particular vote, the stake, and whether you have claimed your rewards or not for this particular vote. Then I have a poll. So for every challenge, there needs to be a poll. So as soon as there is a listing is challenged, you need the community to come in and vote whether it should be there or not. So for every challenge, there will be a poll. So this is the poll struct, where we have the total number of tokens for votes and for against votes. Then till basically what date I can accept votes for this particular poll, and then if it is the pass means here simply that if the poll has been in the favor of the listing or it is in against the listing. So if it is passed, then the listing has been accepted in the registry. If it has failed, then the listing has been rejected from the registry. And finally, I'm also maintaining a mapping of votes inside this, because every poll will have a list of votes from different parties or from different people. Then we have the struct called challenge, and again this is very similar to how we have the struct for listings. Similar kind of information on what is a stake put behind this challenge, whether it is resolved or not. And then finally, this is the reward pool, which is available for participants to claim after the challenge has been resolved, and how many tokens were received for this particular challenge.
So the reward pool, is it primarily formed by the staking party, like the new potential candidate into the listing, or it's also from, in addition to that, to their kind of submission fee, there is like the tokens that are at stake by the curators. So is the reward pool is a combined pool from all of it?
It depends upon which way the challenge has resolved. I'll come to it just in a few minutes.
Okay.
Then I am actually maintaining private mappings for listings and challenges. I don't want to expose them publicly because of obvious reasons. And then similarly, the listing, and this is just to make sure that I'm deleting it from the place where I want to delete it from. So just making sure that I'm maintaining a list of an array of indexes for my listings, because when the listing is rejected, it should be deleted. And then finally a mapping for polls as well. A few variables here and there, like I want to understand what is the token for this particular registry. So I will go to the token contract in a bit, but it is a very simple ERC20 token contract which I have for this. I need to name my token curated registry, like the one we saw was called @chain. This will be something like Gotham chain. Then we need the parameters over here. So again, in @chain, these parameters are driven using curation as well, but here we have just hard-coded them for simplicity. So, and then again, like I said, I'm not using reveal period and vote quorum and what dispensation percentage, because my formula is hard-coded in this one. So I'm only using the three most important ones: minimum deposit, apply stage, and commit stage.
And what's the hard-coded value of dispensation?
I'll come to that. When I'm resolving the challenge, there is a formula that I have put over there. I have not used the percentage at all. It is basically completely dependent upon what you have contributed. So if you have contributed X, you will be getting in return in proportion to that.
Okay.
Then I've initialized some values, because and this is exactly taken from the PLCR voting, where you need an initial you can say value for a poll nonce, and then you increase it per challenge, and some events to make sure that I'm getting the required information and something is completed. And finally the initialization. So when I'm initializing this particular registry. I'm passing in a name. I'm passing a token address, which is already deployed as an ERC20 token, and I'm passing some parameters. So basically, these parameters are again the same ones we saw earlier, and they are being initialized in the constructor. So at this moment, once the constructor is there, we have our running token curated registry with its own token. All we need to do now is get into the curation. So there are some of these getters that I have written to make sure that I am having some helper functions for my UI. Some of these might not make sense over here, like I have some for loops, reading the whole mapping and stuff. This is just for a simple demo purpose. And some of them are basically needed to make sure that we are doing the required checks. So I'll go to the main function over here, which is the apply function. So all we can see here is that I am doing some checks that this particular application which is coming in is already not whitelisted, because if it is already there, there is no need to apply it again. I am also checking that the amount that we are passing is greater than the minimum deposit, because nothing less than minimum deposit should be accepted, and minimum deposit at that particular point in time when you are calling this. Then basically I am actually storing the object in my struct, which I showed earlier, that all this information that I'm receiving in this apply stage, basically I'm storing it in my struct. I am actually setting an apply stage length, because now the application has been in the apply stage. Till what particular time should I be accepting challenges for this application? So that is where I'm setting expiry. And finally, I'm actually taking the token transfers. So the person who is applying is actually transferring the number of tokens which he wants to put to this particular contract. Now, in a typical ERC20 standard token contract, before this happens, you need to approve or allocate those tokens to this so that this contract can take it from you. So this was the apply stage, apply function, where you have transferred some tokens, put some data on the smart contract mapping. So now your application is in the apply stage, basically.
And one question: the amount of tokens that they apply with, it's not a parameter.
It should be greater than the minimum deposit.
So it could be a parameter.
It is
a parameter.
Yes. So I'm making this check here.
Oh yeah, got it.
So
thank you.
Sure. So then the second stage, basically, once your application is there, anybody can go and challenge it. So the challenge aspect of it. So again, we are checking whether an application is in the apply stage or it is already whitelisted, because if there is no application, we wouldn't want to challenge it. Then similarly, the challenge should not be already there. So again, this is something very important, that there cannot be multiple challenges at the same time, because this is all binary. So if somebody has already objected to your application, why would somebody else want to do that? And then people will start finding it difficult which way to vote. Should I vote for his challenge or should I vote for his challenge? So it's always just one challenge at a time. And then we are setting, basically we are doing some checks, like if it's still in the apply stage or it has passed it. If it had already passed, then we will not accept the challenge, and so on. And then we are storing the challenge basically inside of our struct. Now the more important part over here is also that we are spinning off a new instance of a poll to be associated with this particular challenge. And this is also what is being done in PLCR voting also. What I'll do is, actually, after I walk you through with this one, I'll also walk you through with the Action smart contract, so that you can see the differences. There are some really subtle differences over there which are very important for production scenarios. So we start a poll for this particular challenge so that we can accept and store votes for this challenge. And then finally we take the tokens. So when you are challenging, you need to pass some tokens in. So you are doing that, and that's it. That's you have challenged basically a particular listing. Finally, the voting aspect of it. So we will do some required checks that the application was made or it is already whitelisted. There is a challenge for this particular application, and the challenge is still active. So you can still vote on this particular challenge. The deadline has not passed. And then we transfer the money. And this is the more important part. This is the crucial part where we are actually not using PLCR and we are just revealing all the votes in the front. So we are basically, whatever you have passed here, true or false, we are just increasing the value of votes for and votes again, and it is already revealed. So in a typical scenario, this will happen only when you reveal your vote and not by default. And then finally we store the vote inside our struct and emit the event. So that's basically the voting part of it. So by this time we have actually implemented the apply, the challenge, and the vote, the three basic functions of TCR, and how they are being stored in a smart contract. And now basically I'll start from here. So once the commit period has passed, and basically generally it's the owner of the application or somebody else, they can just go and say that update the status, let's see what happened to my application, whether it was accepted or rejected. So they will basically call this particular function, which is also public, which is basically check whether something can be done about it or not. So first of all, I will check it can be whitelisted without a challenge. So I would like to see that if there was no challenge, if everything went fine and smooth, then I will just say just whitelist it and get done with it. Otherwise, we resolve the challenge. Now, when we say resolve the challenge, what actually happens inside that particular operation is we first of all calculate what happened with our poll. So this particular, we will actually get all the, one second. Yeah. So when I am accepting a vote, I am actually also making sure that I am updating the values, whether it is against or for the challenge. I am using those values when I am ending the poll, which one is greater. So this is where basically the vote quorum comes into the picture. Right now I'm just saying that if it is greater than the previous one, which is the 50-50, then we are good. It can be something else as well, depending upon the value of that particular parameter. So I'm just making sure that I'm checking these values, which one is greater, and then making sure that I'm updating the status of the poll, whether it has passed or not. And then basically once I have ended the poll and have found out whether it passed or not, based on that I'm actually calculating the reward for the parties. So now this is where the formula is hard-coded. This is not basically a dispensation percentage coming into the picture or the rewards. If the poll has passed, that means the application has been whitelisted. So all the people who have voted yes are the winners. And otherwise, all the people who have voted no are the winners. So when I am saying that I want to basically how many total tokens were received, in this particular case, the total tokens received were in support of the poll because it has passed. If the poll has failed, then the total tokens I am setting as votes against. Then I want to see the rewards pool. Basically, what it contains, the rewards pool will be the opposite party, which the people who have lost. So I am not considering basically a dispensation percentage here. I'm just giving everything which has been lost to the winning parties. So for example, if I have voted yes on something and I am in the winning pool, then basically I get what I put for my particular vote, let's say 10 tokens. But in addition to that, I also get a share of the losing party stake. So that's what is being done here. And then basically we do these calculations, store them on our smart contract, and also do one more important thing, that if the poll has failed or basically the application has been rejected, then we delete it from everywhere so that it can be, you can apply it again. So that button that you saw on that chain front end apply for a listing which was rejected is because it has been deleted and you can actually apply. And once the challenge has been resolved, now the contract knows that what happened with a particular listing, whether it passed or failed, how many tokens are there for winning people, how many tokens it needs to return just because people were in the winning 1 second, and so on. So now we have all the information. All we need to do is go and get our rewards. But before that, there's a question. Yes.
Yeah. So when we delete the listings, this then basically results we don't have any history, right?
We do have a history. We are just removing it from, so we have the polls, we have the challenges, we have everything. We are just removing it from that particular portion. And this is also, I think I should have done it a little better from the deletion perspective, but you can say that it must be something really, really elegant in the real implementation, I'm sure of that. Okay, so moving on, we now want to claim our rewards. So a simple check that we are doing here is that the poll has been completed. Challenge has been resolved, so I'm doing a simple check because I cannot claim anything before the challenge has been resolved. Then I actually find out what my vote was. So generally the idea is that I will be claiming my own rewards, so that's why it's message.sender on votes. So the account that I'm calling this function from, if this particular account has been used for voting, then this particular account will get the results or the rewards. So basically, this amount has now been this is where I'm calculating the amount. So the reward is basically whatever I gave for my vote. And before that, actually, there is a small check that I'm doing here, whether I'm in the winning party or not. So if the poll has passed and my vote was true, that means I'm a winner. Or if the poll has failed and I voted a no, that means I'm a winner. Otherwise, I'm not. So in case if I'm a winner, then my reward will be calculated based on this particular hard-coded formula, and that's where the simplicity, because of simplicity, I put it here, that I get what I put on my vote and also a share of the money which was, or the tokens which was there from the losing parties. And then we do a transfer from the smart contract to this particular account, and the reward is claimed. If I'm not in the winning party, then I don't get anything. I still basically make sure that I'm setting it up so that I don't have to do it again. So this is a very simple, you can say, implementation of a TCR. It is just like showing the very basic functionality, not to be used in real scenarios because of obvious reasons that there is no vote revealing, there is no dispensation percentages and all, but it helps you understand the basic ideas on how token curation can help with smart contracts. Yes, please.
Is there?
Could we see the vote function?
Come again?
Could we see the vote function?
Yes. There we go.
What if I vote twice?
So then you have to put your votes on both of them. And actually, I have made some sort of check here, or maybe if you vote twice, your previous vote will be overwritten because you are voting for the same challenge.
And I'm losing it even in case of successful voting, in case of victory.
So let's say if you have voted yes, and then you come back and vote no, so now your vote is no.
No. If I vote yes, and then I vote yes for the second time with another stake, then I think my vote will be overwritten in line 200.
Yes, it will be overwritten in this one, but not in the real implementation.
I see.
Yeah.
In case you need the security audit of your real implementation, contact me.
Sure. Thank you so much. Yes, please.
Is there any reason or incentive to stake more than the minimum amount?
Yes, because the more you stake, the more will be needed for challenging.
Okay. So if when you apply, you stake with a higher number, the challenge needs to have that amount of tokens as well.
Yes, and then at a later stage, you can, once your application has been whitelisted, you can actually remove your tokens below,
Okay.
which are more than the minimum deposit.
Okay, but there's no maximum.
There is no maximum.
So if someone buys a huge amount of tokens just for that part, applies, gets accepted, and then removes, it's really hard for anyone to challenge.
I guess that's what's happening with the Twitter.com thing. Actually.
Okay.
Yeah. Okay.
Is there like, can you show like this dispensation percentage parameter?
I have not implemented that on this one.
Okay, so basically it's 100%.
It's
Here.
100%, yes.
Okay.
Yes.
But
all
what would be the use case for less than, like, where would the remaining go, or when and how would you use this dispensation percent parameter?
Actually, even I was not very sure of that, and that's why I did not implement it here. So I was kind of finding it also hard to find a right percentage for winning parties and the rest of them for giving it back. So I just left it there, basically.
Okay.
Yeah,
So it may be used for like refunds, or?
could be.
Okay. I see. And another like overreaching question is, what are the incentives, if any, for early curators or for early entrance, right? Like either anything that gives an advantage to those who come in and start bootstrapping this list from like nothing versus those who come in, let's say, a year later when, oh, now there are a lot of applicants, right? Now I can curate stuff. Like, would either an incentive to join early for something like that implemented, let's say for Ocean, and there is a list of data sets, like, why would I come in and join early?
Yes, the value of the token. So
Of the TCR.
yes. So the value, when the TCR is empty in the beginning, the value will be nominal. As and when it starts gaining more and more, you can say, attraction from the consumers, more and more people would want to have their entries on, and then the value of the token will go up. So if you are coming in later, then you have to purchase the token at a higher value to curate it.
But if there is, let's say, an inefficient market, is it where you would plan to apply the curve bonding?
I didn't get your question.
Like,
actually.
for example, yeah, it's an early market, the value of the token is small, right? But the token with no liquidity, no price, there is nothing that sets the price. It just basically is wild west, subject to all the manipulations and all of it. So how would you solve this? Let's say you may have 1,000 data sets, right? And yeah, the price for those tokens is very cheap. People would just buy them up, right, and wait. While they buy them extremely cheap, but they don't plan to do any work, and they're effectively abusing the system.
So this is a very realistic, you can say, problem with these kind of systems, that you definitely need some sort of bootstrapping. So you need to have some sort of real values in the system in the beginning, so that people can be attracted towards it and start contributing to same kind of quality. So if you already have some values in the beginning, then people will see, okay, this is really good list. Let me add. If I am there, I might also be considered good. So let's put it there that way. So you will need some sort of bootstrapping definitely. But yeah, this kind of is a chicken and egg problem. But I think with time it gets resolved. Like now I see AppChain has really good values coming in, like there are values being rejected and stuff. In the beginning it was not the case, so it takes some time to get the proper bootstrapping on these systems.
Okay, and in the AppChain case, do they have just a TCR where AppChain token is the token
Yes.
of the TCR?
Yes.
So they're basically one TCR with, okay, so this problem, it's not like there was no demand, zero demand for tokens, right? But if it's a long tail of those TCRs, in your case, I assume you plan to use TCRs for what, like to have one big one or many?
I cannot comment on that actually because I'm not very familiar with the ocean architecture on what is being implemented over there, but there is definitely some sort of research going on on the TCR side. That's basically my you can say knowledge at this moment.
Okay.
Yeah.
Thank you.
Okay, so let me quickly also show you the at-chain contracts as well, just to see what are the differences that we have over there. So what we have here is this. The registry contract is the main one, where we have the TCR and everything, and you can say like I mentioned before, the implementation that I showed you previously was just for walking through this workshop, covering it in the specified amount of time. But this is the production ready implementation, as we can say, from at-chain team, and a lot of things are similar, a lot of things are very, very different. So for example, all of the parameters are being imported through a factory, and then there is a whole different contract for voting. So this is called partial log commit reveal voting, which is basically being used over here. So not anymore a simple list of true or falses, but an actual commit reveal voting system is being implemented. And this implementation is the partial log. I was reading a blog post on this one, and this is really, really elegant. They have used doubly linked list to basically make sure that the votes are being sorted in proper order with respect to their weights and everything. And it's very elegant. But at the same time, when you come across these concepts of TCR and just simply proposing, applying, and challenging and voting, going into that much depth does not give you a good, high-level overview. So that's why I skipped a lot of these things. But if you look at this particular contract called PLCR voting, then there is a doubly linked list also implemented as part of it, which is basically this. So there is a library which makes sure that all the votes are correctly organized with respect to their weights. And then we have
where's this code coming from?
This is all from the at-chain team.
Okay.
Yeah, I've just cloned the repo and I'm showing it on my local.
Thank you.
But this is all from, this is again, if you will, once you have cloned the repository that I showed previously, it's all there. This is the code which is coming from. This is the code. So this is the voting contract which is being used for the TCR implementation, where we have reveal period coming into the picture. We have commit period is fine, but then we have here the dispensation percentage coming into the picture, total number of tokens for winning, and we have a different way of starting a poll over here, where we are basically taking into consideration the vote quorum as well. And the more important thing is basically this part. This is where the whole different implementation comes into the picture, when you can actually go and reveal your vote at a later stage in time, and making sure that your tokens are counted for your vote only when you reveal them. They are not counted when you have not revealed them. So and that's where the doubly linked list comes into the picture, because that's when the amount will be deducted. So a lot of you can say things are happening in the background in these contracts, which are making it you can say human proof. Like we were discussing in the beginning, what if people collude together? What if people can see the votes and sway the things on one side? All of that basically is being made human proof by these contracts.
And what is the rationale for letting people reveal it, like to signal their votes, or?
Yes, so revealing means basically you are telling the smart contract what you voted for.
And so in real life scenario, why would someone do that? Like just to
because otherwise the vote will not count.
Oh, okay, got it. And so the revealing must come before the deadline, right?
Yes, yes.
Okay. And what if I don't reveal before deadline, then my vote doesn't count?
Yeah.
Okay.
So that's taken from ENS.
Mhm.
The reveal schema that's taken from ENS.
Yes.
Ethereum names.
Ethereum name service is where you bid on a name, you have a time. Then if you don't reveal, you don't get the name.
You can say something similar, but not exactly the same, because that's where it's like that is the domain name you are trying to purchase, and you have to reveal your bid. In here, you are revealing your opinion. So those are slightly different things. Okay, so I think that's primarily what I wanted to cover in this particular workshop. Help you walk you through the concepts and also walk you through the implementation aspect of it. There is also a repository which is the front end for this, which I'm currently working on, and I will finish it pretty soon, hopefully in this week itself, where I've created a simple React application, and this React app actually shows all the listings on the front page, and then you can actually challenge and vote and apply for these. So right now it looks in a very, very nascent stage because I was stuck with some React things earlier today, but this will be done, and then we will have a complete picture on what is there. So if you want to use this or check this out later, please feel free to do so. And if there are no other questions, then thank you so much.
What kind of help do you need further with this development? Like,
so right now, what I have here is a very simple list. I still want to add a few buttons in there, and so the smart contracts are all wired. But what I'm currently struggling with is some React, because I'm very new to React, so I'm still learning it along the way. Adding the state management and everything, so that's being worked upon. Yeah.
Well, a nice kind of acceleration of this, like this UI and this whole process might be an integration with something like Aragon for governance on parameters, because otherwise they're basically tied into whoever, like single dude or 5 people decide on parameters. As if I were to use and make a significant investment into becoming a curator, right? I would like to understand how decentralized the decisions on changing the parameters. 6 months later, you will change the percentage parameter to 5%, and my reward will be cut. So
actually, it is already being covered in the token curated implementation from the AdChain team. So the parameter side, basically here, there is challenges and proposals for parameters also.
Oh, got it. So the governance is like embedded. It's
yes.
like
TCR.
This is cool.
Yeah.
So,
so if these parameters were hard coded, then it would have been a really, really highly opinionated list already.
Got it. So it's like a submarine with embedded generation of oxygen, right? They generate water and oxygen.
Yeah, and also deciding the depth.
And deciding what?
The depth.
The depth?
Submarine depth.
Yeah.
Do you know maybe of any TCR projects that also have reputation?
Reputation.
As a second parameter.
I think the Weave team was working on something called as a graded TCR, or right? The Weave.network. There is a team in Berlin, Weave network.
Okay. Weave.
I'm not sure if they are implementing it or not, but there was a post it was ranked or graded TCR or something, where there was some mention of a reputation. But the idea was you move from one list to the other list. You don't get a ranking inside the same list. It is that there are 2 lists. Then one is rank here, one is rank here. So you basically climb a step and move to the next list.
So it would be, if let's say if the reputation is expressed in like stars, you would move them from 3 star to 4 star.
Yes.
Or from 489 credit score to 490.
Something like that. Yeah.
Okay.
Aragon is working in something related. They are placing a marketplace within the Aragon framework. So you have core applications like voting, funds, payroll, and then they're opening a marketplace where everybody can publish an application. It will go through a TCR, and I believe that they might be injecting some kind of reputation.
Huh. And TCR would be for basically like a certified kind of like.
No, accepting it or rejecting the application to be listed.
Could be like App Store, you know, you have
App Store.
App Store.
So
where you
App
have
Store
apps
basically
listed,
decentralized
you have
App
ratings.
Store.
Yeah, cool.
You have ratings.
Well, but that's like they may have ratings, but what Noel said is, I guess you either in the App Store or you don't, right? So just like in the App Store, they review your app, and then we deny it.
So
Cool.
also AdChain basically has, okay, the one who wants to be on the list pays a stake. Then if I want to challenge that, I pay the same stake, and then also those who vote pay something for voting, right?
Yeah.
Do you know maybe of any projects where there is a big asymmetry between the applicant and the challenger? So let's say I have a list of companies, and those companies, to be on the list, they need to stake a lot. And individuals can challenge them, but let's say Coca-Cola is on that list, I as an individual cannot then challenge with the same stake as Coca-Cola put it in, so there's this asymmetry.
But
Do you know maybe any TCRs trying to tackle this?
Pepsi might challenge them.
But okay, this is then, you know, but then it's between Pepsi and Coca-Cola, then we exclude the individuals.
Well,
It's gonna be useful. Useless list.
as long as
Why?
as long as creators.
Only two companies, right? Only the rich ones.
Yeah, I mean, if only the rich can challenge each other.
But as long as curators can deny the Coca-Cola, if it's a binary list, if it's objective, then you can stake $1 million if you're not on a list. If you're getting denied, the $1 million goes to poor people, right, to curators. If it's decided yes, then the Coca-Cola. If decided no, then Coca-Cola basically loses it, right? If it's yes, then I guess it's returned to the Coca-Cola, right?
So basically, if I understand you right, you're saying that, okay, let's say Coca-Cola pays million of tokens to be listed, and I as an individual challenge Coca-Cola, and I put like 100 tokens to this challenge, and this difference does not matter.
Well, it may matter. Like I see biggest like.
Because then I can imagine Pepsi hiring a lot of people. Just
The biggest problems are probably the attacks come from the very big value of the cost of becoming the curator, and if you have very cheap cost of doing the curation, you can basically selectively deny Coca-Cola just by buying enough tokens, just not to get them on a list, right? That's probably like biggest attacks from the, if it's very bootstrapping, like very small phase, someone may constantly like mess around with, for them it may be small price to pay, they know they're gonna lose, right? For example.
Okay. Yeah. This is something we need to solve.
Interesting. It's mature. Cool.
Thank you.
And is there a parameter to actually make some minimum ratios, for example? So basically, like if someone is adding, putting a reward, basically, and if a deposit, the application fee is, let's say, $1 million, right? And the value of TCR is so tiny, right? Is there a way to like change parameters, how much minimum stake by curators needs to be there?
So what I see is that this is still, you can say, a new framework. A lot of changes can be implemented. So you can introduce parameters like, for example, in one of my projects, we introduced a parameter called minimum stake for voting. So you need to have some sort of minimum stake before you can vote. So you can always introduce something which you can say use in your business logic on the smart contract. So I don't see why not. It's still an open framework. You can actually mold it the way you want, as per your needs, as per the people involved in this particular this thing. I will not be surprised if the next day there is just not the proposals in these parameterizer. There could be something like propose a new parameter and then propose a value for that and then do staking on that. So there can be a lot of opportunities over here, I think.
Yeah, and the reference implementation, it has a lot of parameters that probably you didn't cover here.
Yeah. Yes.
In the factory, and there's the configuration
these
file.
are the parameters. Yeah. So a lot of them are here.
Yeah, I know Golden is added a couple of later after the article you showed. Do you also, before when you said about Viv network, did they move you to a different TCR?
It was there in one of the blog posts, but I'm not sure if they have implemented that.
So then they basically use the same token for multiple TCRs? Do you know this maybe?
I guess yes. Or maybe the value of, I'm not very sure on that basically, but this is one of the design patterns that came out that is a graded TCR, so you have different grades between different TCRs.
Thank you.
Okay. Thank you.